Welcome to the first video of this series. This series is designed for people with a limited knowledge of algebra and mathematics in general. It should be accessible to all levels, from beginner to advanced mathematicians. By the end of this series, you should have developed a strong intuition for the foundations of mathematics, which are used across a wide variety of disciplines. So I chose to begin with number systems as chapter 1, since number systems pretty much encapsulates everything we're going to be doing in the next while. So number systems are just sets of numbers, and a set is a well-defined collection of objects. So an example of a well-defined set would be the set of all whole numbers between 1 and 10, whereas the set of good musicians isn't a well-defined set, since it's a subjective opinion. Now we will be learning a lot more about sets in a future video, so I wouldn't get too worried about the definitions at the moment. So here we've got the set of natural numbers, which is just a set containing all of the positive whole numbers which are greater than 0. So positive numbers are just numbers that are greater than 0, and whole numbers are non-decimal numbers, they're whole. So I can write a couple of different numbers down. So we've got -5, -3, 1, 7, and 50. Now 1, 7, and 50 are all positive whole numbers, and -5 and -3 are negative whole numbers. -5 and -3, just like any negative numbers, are not elements of the set of natural numbers. The set of natural numbers is denoted by the capital N, and the curly brackets tell us that we are talking about a set of elements. An example of an element of this set would be the number 5, the number 3, the number 1, the number 5,000, the number 1,000,000, and so on. The ellipsis, or the 3 dots at the end of the set, tells us that the set continues in the same fashion all the way until infinity. This is also indicated in the number line by the arrow pointing towards the right. Number lines are very effective at representing different sets of numbers. You can see here that this number line represents all of the natural numbers from 1 to infinity. Now, the reason that I said 1 to infinity and not 1 to 6 is because the arrow at the end of the number line stretches all the way out to infinity. You might notice when taking a look at this number line that non-whole numbers are not plotted. For example, 1.5 is not plotted on this number line. That is because decimals are not elements of the set of natural numbers. Okay, so now that we know what the natural numbers are, we can start actually working with these numbers. So taking a look at the numbers 18 and 45, it is easily shown that these numbers are made up of different products of numbers. For example, taking a look at the number 18, I can make 18 by multiplying 1 by 18, 2 by 9, or 3 by 6. In the same way, I can make the number 45 by multiplying 1 by 45, 3 by 15, or 5 by 9. Since these pairs of numbers make up 18 and 45, we can say that they are factors or divisors of 18 and 45. A factor is a number that divides another number with no remainder. So you can see if you divided 18 by 1, you would get 18. If you divided 18 by 2, you would get 9. And if you divided 18 by 3, you would get 6. Some numbers have common factors, which are just factors that are common to both numbers. So for example, 18 and 45 have the common factors 1, 3, and 9, because they can all be divided into 18 and 45, leaving no remainder. The highest common factor of 18 and 45 is 9, since 9 is the largest whole number which can be divided into 18 and 45, leaving no remainder. So this is the end of the first part of number systems. In this section, we've covered natural numbers and factors or divisors. In the next section, we will look into integers, multiplication and division of two integers, and the order of operations. Thanks for watching, and I'll see you in the next video.